I want to talk to you today about electron configuration, which is one of the harder things to read about and understand. So I'm going to make it quite easy for you. So all of this, first of all, I need to tell you, is a story based on observations about elements. So scientists observed things and then they made a story to fit the observations. So electrons, of course, are something you cannot see. We can X-ray them, but we can't see them. They're just too tiny. So here is the story. So electrons will occupy energy levels. That's the main area where they occupy, kind of like you live in a country. Okay, now that's not the only place where you live, but that's kind of my analogy here. So energy levels are indicated by n equals 1, n equals 2, n equals 3, etc., up to n equals 7. Okay, now kind of an unusual thing here is we have filled the periodic table. So if another element is made, it won't be discovered, it will be made in a laboratory somewhere. We would actually need to go to n equals 8 someday. All right, so don't worry about that right now. And that number refers to those periodic rows, okay? The periods, those correspond to the periods of the periodic table. And on a lot of periodic tables, that's labeled on the left-hand side, 1 through 7. Okay, then we have sublevels, and for some reason, they are given letters that mean absolutely nothing to us, but maybe to scientists. S is the lowest energy, then P, then D, then F. All right? So S is the lowest energy. And by the way, in energy levels, 1 is lower than 2, is lower than 3, etc. All right, so in terms of our analogy, you live in the United States, but your sublevel is Virginia, for most of you. Now, exactly where do you live, though? Okay, you live in a house. Well, electrons live in orbitals. Okay, that is the place where they reside. And orbitals can hold maximum 2 electrons. That's it. And they spin in opposite directions. So when we're doing orbital diagrams, we'll show that spin with an arrow going up and an arrow going down. Okay, so that's one orbital. Now, just because it gets a little filled up and a little tight in some of the drawings, sometimes in textbooks they show the arrows as just a one-sided arrow, okay? And I will too. So let's talk about how many orbitals then each sublevel has. S contains only 1 orbital. Okay, now don't forget, it holds 2 electrons. P holds 3 orbitals. Each one holds 2 electrons, so that's 6. D holds 5 orbitals, and so that's 10 electrons. And F holds 7 orbitals, meaning a total of 14. And you can see a lot of that information in your textbook on page, somewhere in through page 340, 335, something like that. Your book uses some things called NLM and M3. We are not going to use quantum numbers. We're just going to use energy levels, sublevels, and orbitals. Okay, now before we start coming up with the address for each of these elements, there's some rules for how the electrons fill these orbitals. Here are the 3 rules. The exclusion principle, which says that orbitals hold a maximum of 2 electrons. the Aufbau principle, which says that electrons occupy orbitals from the lowest energy to the highest, and Hund's rule, which says that electrons do not double up unless they have to. So let's go ahead now and get an address for some element, okay? So, and that address is called the electron configuration. So let's do carbon. Okay, carbon has 6 electrons. So, the first place that they can go is the first energy level, which is 1. And then they're going to start occupying those sublevels. So the first sublevel is S, okay? And that can hold a maximum of 2 electrons. So we signify that with a superscript, okay? So our electron configuration is going to have the energy level designation, the sublevel designation, and the quantity of electrons. Okay, now that's only 2. Now it turns out that the first energy level only has 1 sublevel. Okay, let me put that here. N equals 1 has only 1 sublevel, and that is S. The second energy level has 2 sublevels, S and P. The third energy level, I guess you can guess this, has 3 sublevels, and that is S and P and D. And equals 4 and beyond have 4 sublevels. Now maybe the story is going to change in your lifetime. I don't know. S and P and D and F, all right? So as you go up in energy levels, you're going to be able to hold more electrons. Okay, so down here for carbon then, we have filled the first energy level. Let me do this in red. Okay, so we need to go to the second energy level. And remember, we're going to fill the S orbital first. It can hold 2 electrons. So now we've got 2, 4 electrons, okay? But we need to get 6 in there, okay? So don't forget, we have a 2p. And we only need 2 there. Now, P can hold 6, but in this instance, it doesn't need to because carbon only has 6 electrons. So that is called carbon's electron configuration. If you go to page 340, there's a bunch of elements listed there with their electron configuration. And I suggest that you try some and then look back and see if you've got them right, so you have kind of the idea. Let's go ahead and do nitrogen. And nitrogen has 7 electrons because it's right next to carbon. Well, of course, we're going to start out with the same designation, 1s2, 2s2, because they fill in the same order. But this time, 2p doesn't have 2 electrons, it's going to have 3, okay? So as you can see, these superscripts add up to how many electrons. Okay, that's it for electron configuration, and then we'll add on to that a little bit in the next video or Zoom lesson.